Hello and welcome again. We're going to talk about rewriting formulas. That basically means solving an equation that could have any number of variables in it, solving that for a variable, which means getting that variable by itself, as if it is the only variable in the equation. We've already done this a little bit, and we've seen lots of formulas with multiple variables in them already. Most recently, we've seen our slope-intercept form, right? But we could treat this as just a formula in general, where everything's a variable, and we can then ask what happens if we solve for b, say. That means get b by itself using our normal tools at our disposal of tools of algebra. So I would just subtract mx from both sides. Subtract this whole term from both sides. What I get then is b on this side equals y minus mx. And then I might rewrite that as b equals y minus mx. So that means if I knew m and x and y, I could get b. And that's essentially what we do when we plug in values for x and y, if we know the slope, to get our y-intercept. Another formula we've seen also is our exponential form, a times b to the x. And remember, we had a way to solve for a, the y-intercept for this too. If we wanted to get a by itself, start with y equals ab to the x. We might just divide by b to the x. We don't really care what it is, we're just dividing by it. What that does is it cancels the b to the x is on the right side, and a is by itself now. And I might rewrite it as a on the left. The variable that's by itself I like to rewrite first. Y over b to the x. So that's it. I mean, that's what rewriting formulas amounts to. We're going to look at a couple more examples. One example I like to use is the formula for converting Celsius to Fahrenheit. So if we know degrees Celsius, C, we can convert that to Fahrenheit by just multiplying by 9/5 and adding 32. What if I wanted to find out what the formula is for converting Fahrenheit to Celsius? Well, all I would do is solve this equation for C. So what we'll do first is subtract 32 from both sides. We've got F minus 32 equals 9/5 times C. And then I'll multiply both sides by 5/9. I've noticed I'm multiplying the entire left side by 5/9. The 9's cancel, the 5's cancel on the right, so C's by itself now. So our formula for Celsius is 5/9 times the quantity of F minus 32. And that's pretty much it. Now you could distribute that 5/9 through, but I wouldn't recommend it. It's a little bit cleaner this way. So this is fine. Do this with any formula you're given, pretty much. Any formula at all. Here's one. D equals R minus A minus BC. The instructions I might give you for this is solve for B, say. So we have a term with B in it, so we have to get that by itself first, and everything else on the other side, regardless of what it is. And then when we're done with that, we'll divide by the C here on both sides to get rid of it. So first, let's get this term by itself. I think what I'm going to do is I'll subtract R from both sides, and I'll add A to both sides. I'm going to do them both at the same time. That gives me on the left side D plus A minus capital R. That equals negative BC. Don't forget that negative. Then I'm going to divide both sides by negative C because I want to cancel that negative as well as getting rid of the C. So let's divide this by negative C. So the C's go away on the right. The negatives go away on the right. We're left with B. So our answer so far is B equals D plus A minus R all over negative C. And that's technically correct, the best kind of correct. But that negative on the bottom is kind of annoying. I might want to distribute that negative through. In other words, I'm going to write it like this. Bring that negative out front, or at least move it to the top. D plus A minus R. And that's the sense that I mean I'm distributing it through. I'm not going to distribute the C. I don't think I have to do that, but I'll distribute the negative, and we'll see what happens here. That means we get B equals negative D minus A plus R. It switches the sign of every term on the inside. Still have all over C. And just to be a little bit cleaner, I might say B equals R, do the positive term first, minus A minus D all over C. And that's about it. That's it. Several steps there were just me simplifying it, but that's basically it. Here's the next one. V equals 4/3 pi r cubed. Now, there's only two major variables here, V and r. You might recognize this formula as the volume of a sphere with radius r. But say I knew the volume of the sphere and I wanted to reverse engineer what the radius was. Well, I could make a formula for the radius in terms of the volume by just solving this formula for r. So let's solve for r. First thing I want to do is get rid of this 4/3 and this pi that's here. You can do this all at once or one at a time. But regardless, you're going to multiply both sides by 3/4. And you're going to divide both sides by pi. So I'm just going to say 3 over 4 pi. 3 divided by 4 pi. See how that works? Just dividing both sides by pi is the same as multiplying by 1 over pi. That does wonders to get rid of this 4/3 pi. That 4 cancels with that 4, that 3 cancels with that 3, the pi cancels with that pi. And on the right side, we just have r to the third. On the left side, we have 3 times v. Remember, this v is v over 1, so that's 3 times v over 4 pi. Now I want to get r by itself. I don't want r cubed. If I just wanted the cube of r, I'd be done. But if I wanted to solve for r, well, then I have to take the cube root of both sides. And since it is a cube, there's no need to worry about positive or negative possibilities. Any odd power, if I'm taking an odd power root, you don't have to worry about the pluses and minuses. It's only with even powers you have to worry about that. So I think I could just take the cube root of both sides safely. Or you could say take both sides to the 1/3 power. But I'll just write the radical here. This cube root gets rid of the third power. And so my answer is r equals 3v over 4 pi. I oftentimes write this first because it's hard to write it inside the root. Cube root of 3v over 4 pi. And that's it. Now I'm going to go back up. I'm going to take this opportunity to, now that we've talked a little bit about solving formulas for different variables, to look at another form of the equation of a line, called the point-slope form. Now we already looked at the standard form for a line. That's ax plus by equals c. So we could solve this for y, just like we were doing with the other formulas. If you'd like, try it out. See what you get. Try to get it in a slope-intercept form. Speaking of which, we've already talked about this. Slope-intercept form for a line is y equals mx plus b. The m is the slope. The b is the y coordinate of the y-intercept. And there's a third equation of a line. A third form, point-slope form. Now with this form, if you know a point that's on the line and the slope, you can use this formula, to get an equation of the line immediately. You can plug the point in and the slope and you'll be done. Maybe with a little simplification. It's a lot quicker than plugging in the slope and then plugging the x and y coordinates in of the point and then solving for b. It kind of does all that for you. And where this comes from it's why this is in the section is it comes from the formula for the slope. So I'm not gonna write the point slope form up down just yet. I want you to kind of see where this comes from. It's pretty cool. So say we've got our line. Say we've got any line, doesn't matter. Here's a line. And here's a point that's on the line. We'll call it x1, y1. Now, any other point on this line, well, I'll call it xy, any other point will make true the equation y equals mx plus b. It'll make true the equation of the line. And in fact, it'll make this particular equation true. How you calculate the slope. We could calculate the slope as before. Take the difference of the x's, which is x minus x1, and the difference of the y's, y minus y1. And we can calculate the slope. On the top, we get y minus y1 divided by x minus x1. Change in y over change in x. That's all it is. But check this out. Let's solve this for y. Well, there's our y. We want to get that by itself. So what do we have to do first? Feel free to pause and see if you can't figure this out. What I will do is, this guy on the bottom, this x minus x1, I need to multiply both sides by that. I'm going to multiply both sides by this x minus x1. I'm treating that x minus x1 as an object, as a thing. Just multiply both sides by it, and that whole thing will cancel on the right. Now, I'm not going to do anything. I'm not going to distribute that m through on the left just yet. Let's just rewrite what we have. X minus x1 times m. I'm going to put the m on this side because that's commutative law. That's legal. Y minus y1. Almost there. Now we just have to add y1 to both sides. And so we get m times x minus x1 plus y1 equals y. If we write y first, guess what? That's our point-slope form. That's what a point-slope form looks like. Y equals m times x minus x1 plus y1. So if you know the slope of a line and a point on it, you can just plug the slope in here and the x and y coordinates of that point, and you'll be done. You'll have an equation of the line. Now, if a problem asks that they want the slope-intercept form, you'll have to distribute your slope through there, and you'll have to combine some like terms. But if you just want a quick and easy way to get an equation of a line from a point to slope, this is the way to do it. Find an equation of the line through 7, 5 with a slope of 2/3. There's our point x, x1 and y1, and here's our slope m. So an equation of the line is m, which is 2/3. X is still a variable, but we subtract the x coordinate 7, and then we add the y coordinate 5. That's it. That's an equation. Again, technically correct. That's kind of correct. If we wanted the slope-intercept form, we have to do a little bit more work. But I kind of like starting with a point-slope form in this case because it's not too hard to just distribute that 2/3 and collect some like terms. So I just write this, y equals 2/3. Distribute that 2/3 to the x and the negative 7. 2/3 x minus 2/3 times 7 plus 5. That's 2/3 x minus 14/3 plus 5. And now the only step we have to make in order to find the y-intercept here is to combine the negative 14/3 and the 5. Well, 5 is 15/3. So this is just going to be 15/3 minus 14/3. It's pretty slick. It worked out nicely. So y equals 2/3 x plus 1/3. That's the equation of the line. Pretty neat, huh? All right, so that's all I have for now. I'll see you next time.